Bottom line, I simply want to make ever better car, no matter what kind of the powertrain they have.
Imagine a battery that can run for more than 1,000 kilometers on a single charge without being affected by cold, heat, or rough roads. This is no longer a dream, but the reality of Toyota's new solid-state battery, which has shaken the entire EV industry. While Elon Musk and Tesla have been making bold claims about their 4,680 cells, Toyota quietly worked behind the scenes, and when its prototype was revealed, even Musk was surprised, as Tesla's battery technology could not match this breakthrough. This is not just a battery, but a revolution that addresses all three major EV challenges: range, charging time, and battery life at once. Naturally, this raises big questions. Is this the end of Tesla's dominance? Will Musk have to rethink his strategy? And is Toyota on track to become the new king of the EV world? The answer seems to be yes, but to understand why, it's important to look at the story and technology behind it. Toyota, once the king of petrol and diesel cars, has already made its mark with hybrid vehicles like the Prius, and now it is rapidly climbing in the fully electric space. In 2023 alone, Toyota sold around 1.5 lakh EVs worldwide, 4 times more than the previous year, and is now targeting over 1.5 million EV sales annually by 2026. The company has established dedicated EV factories in Japan, the US, and Europe, developed its Beyond Zero (BZD) EV platform, and is investing heavily in advanced batteries. While it once lagged behind in battery technology, Toyota's new generation lithium and solid-state batteries have become its biggest strength, with research hubs in Japan, the US, and Germany. The company has already announced that mass production of solid-state batteries will begin by 2027 or 2028. Unlike competitors who seem to be slowing down or retreating, Toyota has quietly entered the EV race with potential to make a massive impact. But what exactly is a solid-state battery, and why is it creating such a stir? To put it simply, most EVs today run on lithium-ion batteries, which use a liquid electrolyte to transfer lithium ions between electrodes. This liquid makes the batteries vulnerable. Overheating, leakage, or high pressure can cause explosions or fires, something we've often seen in news reports about EVs or even smartphones. Solid-state batteries solve this problem by replacing the liquid electrolyte with solid materials such as ceramics, polymers, or glass. The result is a battery that is far safer, almost immune to fire or explosion, leak-proof, and capable of withstanding high temperatures. In other words, it is an ultra-safe, explosion-proof technology that could redefine the future of electric vehicles. The advantages of solid-state batteries are truly groundbreaking. The first is their higher energy density, which means they can store more power and allow cars to travel much farther on a single charge, up to 1,000 to 1,600 kilometers, compared to the 400 to 500 kilometers possible with conventional lithium-ion batteries. The second is ultra-fast charging, with solid-state batteries capable of reaching a full charge in just 10 to 15 minutes. The third advantage is battery life. While lithium-ion batteries typically weaken after 1,000 to 1,500 charge cycles, solid-state batteries can last for thousands of cycles without losing performance, giving EVs a lifespan of many years before requiring a battery replacement. The fourth benefit is environmental sustainability, as these batteries are more durable, easier to recycle, and made with materials that are considered more eco-friendly. However, the challenge lies in production. Solid-state batteries are currently very expensive and technically difficult to manufacture at scale because they require special materials and new processes. Still, companies like Toyota, Samsung, and QuantumScape are rapidly advancing in this area, with Toyota announcing plans to launch solid-state batteries by 2027 to 2028 that could offer 1,000 kilometers of range and 10-minute full charging, potentially sparking a new revolution in the EV industry. This raises the question, why hasn't Tesla moved towards solid-state batteries yet? Elon Musk himself has said the technology is extremely complex, which is why Tesla has focused instead on its 4,680 cells. But with Toyota and others racing ahead, the pressure on Tesla is mounting. After all, when it comes to EVs, buyers always ask the same critical questions. How powerful is the battery? How far will it run? How fast will it charge? And how long will it last? Tesla's 4680 battery, introduced a few years ago, was designed to answer those concerns. Named after its dimensions, 46 millimeters in diameter and 80 millimeters in length, the larger cells offer more power, extended range, and reduced production costs. Yet, in the face of Toyota's upcoming solid-state breakthrough, even this advancement may soon look outdated. Tesla's 4680 battery introduced a tableless design technology that allows current to flow faster and generate less heat, and has already been implemented in vehicles like the Cybertruck and Model Y. However, with Toyota unveiling its solid-state battery, the 4680 design now looks outdated. Toyota's breakthrough delivers an impressive range of up to 1,000 miles, around 1,600 kilometers, and charges fully in just 10 minutes, enough to cover the distance from Delhi to Mumbai in one go without repeated charging stops. By comparison, Tesla's 4680 battery still manages only about 600 to 700 kilometers on a charge and requires 25 to 30 minutes even with a fast charger. The safety edge also goes to Toyota, as its solid-state battery uses no liquid electrolyte, eliminating risks of fire or overheating, whereas Tesla's cells still rely on liquid-based electrolyte, leaving some safety concerns unresolved. Battery life is another area of difference. Toyota's solid-state cells maintain performance even after thousands of charge cycles, while 4680 shows gradual decline over time. Moreover, Toyota's design performs consistently in extreme weather, from minus 20 degrees Celsius cold to 50 degrees Celsius heat, while Tesla's cells require protective measures that can limit long-term efficiency. Although Tesla's 4680 was groundbreaking at its launch, Toyota's progress in solid-state technology signals a warning bell for Elon Musk. Musk has openly admitted that solid-state batteries are difficult and complex, which is why Tesla has avoided them so far. But if Toyota achieves mass production by 2027 and offers cars with this technology at current EV prices, Tesla's technology could quickly be considered outdated. As of now, Toyota's solid-state batteries appear superior in range, charging speed, safety, durability, and efficiency. The EV market is evolving rapidly, and survival depends on constant innovation, not just brand reputation. If Tesla fails to bring forward a new battery breakthrough, it risks being overtaken by competitors like Toyota. The big question is whether Musk will now pivot toward solid-state or unveil an entirely new technology to reset the game. One thing is certain. In the battery race, the company that delivers fast, safe, affordable, and scalable solutions first will become the next king of the EV world. With solid-state batteries addressing not just range and safety, but also easing worries about charging infrastructure, the EV industry is on the verge of a revolution that could reshape the entire system. One of the biggest breakthroughs of solid-state batteries is their ability to fully charge in just 10 to 15 minutes, and then power a vehicle for up to 1,000 miles, or about 1,600 kilometers. This dramatically reduces the need for charging stations every 100 to 200 kilometers, easing the burden on governments and companies to build massive charging networks. Until now, the EV industry was forced to expand fast charging infrastructure because existing batteries either took too long to charge or offered limited range. But solid-state technology solves both issues at once. With such batteries, a short 10-minute stop could power a car for an entire week rather than a single day, meaning fewer charging stations will be needed, infrastructure will become cheaper and easier, and EV adoption will spread even in rural or remote regions. Beyond convenience, safety is another game-changing factor. Unlike current lithium-ion batteries, which contain liquid electrolytes that can react under heat, shock, or damage, and sometimes cause fires or explosions, solid-state batteries use a special solid material that resists heat and stabilizes chemical reactions, making them far safer. This eliminates one of the biggest fears that kept many people away from EVs, while also reassuring insurance companies, regulators, and transport authorities. Additionally, because these batteries are lighter and more compact, they improve both vehicle efficiency and performance. Solid-state batteries, therefore, are not just a technological upgrade but the backbone of the next EV revolution, reducing the need for extensive charging networks, lowering power loads, boosting safety, and strengthening consumer trust. Toyota has already announced plans to bring this revolutionary technology to the market by 2027 or 2028, with global infrastructure being prepared for mass production. The day is not far when we'll see EVs on a road that charge in just 10 minutes and run for 1,000 miles, marking the beginning of a new chapter in automotive history. The production of solid-state batteries is completely different from that of current lithium-ion batteries, requiring new factories, advanced robots, and high-tech processes. For this reason, Toyota is converting its plants into gigafactory-style facilities similar to Tesla's massive gigapress and battery cell production units. The company is building specialized plants in Japan, America, and Europe dedicated solely to solid-state battery manufacturing, equipped with new materials, machines, and automation systems. Toyota's strategy is to first introduce these batteries in its premium vehicles, such as Lexus electric models, to test the technology in low volumes and gather real-world data. Once costs decrease and the system matures, the company plans to scale production and integrate the batteries into its mass-market Beyond Zero (BZ) EV series, making them accessible in mid-range vehicles as well. Toyota's ultimate goal is not just to produce premium EVs, but to create electric cars that can compete with petrol and diesel vehicles on every front: range, charging time, safety, and reliability. To achieve this, the company has invested more than $13 billion in battery research, factory development, and supply chain upgrades. Engineers expect that with rapid progress, the cost of solid-state batteries will fall by 2028 to the level of or even lower than lithium-ion batteries. If that happens, it could be a true game changer for the global EV market. Toyota has emphasized that it is not dependent on any single country or team for battery research. In addition to its teams in Japan, specialized groups in America and Germany are working to make solid-state batteries more durable, affordable, and faster. The company's vision extends beyond just building batteries. It is creating a complete EV ecosystem that includes batteries, charging systems, motors, and electronic controls. With such large-scale preparation, it is fair to say Toyota is not simply making electric cars. It is actively shaping the future of EVs. When Toyota's first production vehicle with a solid-state battery arrives in 2027 or 2028, it will not just represent a new car, but a milestone proving that EV technology has reached a stage where petrol and diesel no longer have a future. It will also signal that only companies embracing innovation in time will survive, and Toyota is clearly racing ahead with full preparation. The announcement of Toyota's breakthrough immediately drew global attention to Tesla, raising questions about Elon Musk's EV empire, which has so far relied on its strengths in range, charging speed, and advanced battery technology. Solid-state batteries could directly impact Tesla's valuation, investor trust, and business model. Tesla is widely regarded as the world's most innovative automaker, but if competitors like Toyota or BYD offer superior technology, investor confidence could falter, jeopardizing the lofty market value Tesla has built. Musk now faces a new challenge. Tesla's 4680 battery currently delivers only 600 to 700 kilometers of range with about 30 minutes of charging, while Toyota is promising 1,000 kilometers of range and 10-minute charging by 2027. With BYD already surpassing Tesla in sales in some markets, Toyota's entry with solid-state technology is like an alarm bell. The pressure is now on Elon Musk to either pursue solid-state batteries or unveil another breakthrough that outpaces Toyota and BYD. If Tesla fails to innovate, it risks losing its image as a global tech leader, a core part of its brand identity. The EV race is no longer about selling cars. It is about winning trust with next-generation technology. For Tesla, that means bold steps in battery innovation are essential to stay at the forefront of the industry.